Let's solve question 3 in this video. So we have a function initially, f of x equals to x cubed plus 2x squared plus x plus 5. And we want to find out the tangent line of this function at the point of 0 and f of 0. So what is a tangent line? First of all, let's get a bit through the theory to understand what is a tangent line. Tangent comes from the word to touch, so a line that touches the graph. We want the tangent line. And let's draw an xy axis just to illustrate the point. So let's put it over here like that. Let's put it something like that. X and y, this is 0, and let's draw the function in such a way. Because it has x cubed and x squared, it's gonna be curvy, so let's make it something like that. This is our function. Now we want the tangent line at the point of 0, f of 0. So at the point of 0, that's when x is 0, the function has this value. This is f of 0, so this is f of 0. What is the line that touches the graph at this point? Well, the line is going to be literally the tangent. If we draw it as a slope that barely touches the graph, this is going to be our tangent line. Now, what does a tangent line have? What kind of form does it have? Well, it is a line, so how do we denote a line? We denote it as m times x plus b, where m is our slope. So we need to know the slope at this point, and we need to know the intercept. Okay, well, our slope is going to be the derivative at this point, and our intercept is going to be the value through which the line passes on the y-axis, and that is f of 0. So we already know that we need to have f of 0 to have the intercept, and we want to find out the slope, which means we want to know the slope at the point of 0. So we want to know the derivative of x in the point of 0. This is something that we still have to find out. And what do we have here? We have the slope multiplied with our x value. So the slope multiplied with our x value. What does the tangent line look like in this case? Well, the tangent line, if we substitute all these values, let's do it right next to it. We said is going to be the intercept, which is f derivative in the point of 0 plus we want to have the intercept, which is just f of 0, that's where we start, plus the slope, which is the derivative at the point of 0, times x. Okay, so this is the line that we're looking for. Let's start solving. What is f of 0? That's the first question. F of 0. Well, we go back to our function and we substitute 0 into x. We look over here, it's going to be 0 cubed plus 2 times 0 squared plus 0 plus 5, and that's equal just 5. So f of 0 is equal to 5. Now we want to know the derivative at this point. To find out the derivative, we first have to know the general derivative of the function, and then we substitute 0. So f derivative of x, that's the derivative of the entire function. So x cubed plus 2x squared plus x plus 5 derivative. Now, what kind of rules are we using here? We're going to use our general power rule for derivatives, which is n times x to the power of n minus 1. So x cubed derivative is just 3 times x to the power of 3 minus 1, and that's 2, plus 2 times x squared derivative. 2 is a constant, so the constant literally stays constant, it does not change, times x squared derivative, that's 2 times x to the power of 2 minus 1, so that's just 2x, plus x derivative is just 1, and 5 derivative, a constant derivative. What is the rate of change of a constant? Well, it does not change, it stays constant, so the derivative will be 0, which means the derivative here overall is 3x squared plus 4x plus 1. But remember, we don't want just f prime of x, we want f prime at the point of 0. So f prime at the point of 0 is 3 times 0 squared plus 4 times 0 plus 1, and that's equal to 1, which means this is our slope. So now we have f of 0, which is our intercept, we have the rate of change, we have our slope. The tangent line will have the following form. The tangent line will have the following form. F of 0 equals to 5 plus the slope equals to 1 times x, and that's just equal to 5 plus x. So that is our tangent line. This is our tangent line. And the question is asking at which x values does this tangent line stay on our function or touch our function. Or if it touches our function, it means they'll cross the same values. It means that they have to be equal. So we will make f of x equals to the tangent line, which means that x cubed plus 2x squared, x cubed plus 2x squared plus x plus 5 equals to 5 plus x. This is our tangent line. Now we have an equation, we have x plus 5 here, we have x plus 5 over here. X and x cancels out, 5 and 5 cancels out, which means we have x squared plus 2x squared equals to 0. If we take x squared as a common factor, in the brackets we're left with x plus 2, and that's equal to 0. When can a product be equal to 0? Either the first term equals to 0 or the second term equals to 0. So we would have x squared equals 0 or x plus 2 equals 0, which means that either x is 0 or x equals to minus 2. And for these two values, our tangent line lies on the function, and we are done.